Got x cubed plus 8, shame on you. How many times do we have to write this out? When you have a binomial and raise it to a power, you have to write that binomial out that many times and do a whole bunch of foiling. So, you would have needed to FOIL 2 of these, then FOIL the third one, and that would have gotten you to the bottom answer. I'm going to be showing you a shorter method today, which you probably have seen before, but nonetheless, it's a good refresher. So, I'm going to show you how to do things like this to the fifth in a fashion quicker than just foiling it a whole bunch of times. And it shouldn't take very long. First thing, oh, these are just kind of nifty little things. We're not going to really... Let me just show you what they are first. Okay, these are called binomial coefficients. And when you see one, here's what it means to do. It means 8 factorial over 3 factorial times 8 minus 3 factorial. And then you would just reduce. Or you can punch the whole dang thing into your calculator, which I would recommend you do now.
What in the world?
That's what this means. That little symbol right there means this. 8 factorial over 3 factorial times 8 minus 3 factorial. And you can punch the whole dang thing into your calculator. I'll get to the point in a second, boy. So, math. What was I doing? Oh yes, 8 factorial divided by the product of 3 factorial. And I'm just going to kind of jump the gun here. What's 8 minus 3? Thank you. It is 5 factorial. So it's 8 factorial divided by 3 times 5 factorial. And you should have gotten 56. Dang you. So that little symbol means to do that. Now the reason they're showing us this is because you could use that for something we're doing today, but I'm going to show you something even easier than using this for what we're going to do. Yes, hit math, scroll all the way to the right, and it's number 4. Okay. Now some of these you're going to find are going to kind of have obvious results, like number 5. 6 factorial over 6 factorial times 6 minus 6 factorial. So cancel, cancel. What's 6 minus 6? What's 0 factorial? 1. So 1 over 1, 1. The ones where it's the same number on top of itself, the answer is just going to be 1. What? Yeah, it's just 1. I don't know why. It's just kind of a law. I don't care. We're not multiplying 0 by 0. We're not raising 0 to a power. It's 0 factorial, and all factorials end at 1, so 0 factorial really doesn't make any sense, so we just put 1. Exactly. Okay. Anybody have a theory about what this one's going to equal? Let's see. 12 factorial over 1 factorial times 12 minus 1 factorial. So 1 factorial is just 1. So that's 12 factorial over 11 factorial. And what all reduces here?
The factorial.
Yeah, the entire factorial and this. Because isn't this 12 times 11 times 10 times 9? And this is 11 times 10 times 9. So everything cancels except for this. So anytime you have something over 1, it's just the top number. And here's the thing. You don't have to remember all these rules. You can just punch the whole thing into your calculator. Just don't be surprised when you get answers like this. You are going to have one later that looks like this, and you can't punch this into your calculator. No, I'm sorry, it's your calculator will say overload because 100 factorial is way too much for it to calculate. But I would encourage you, when you get to this problem, to use logic. If you wrote this out, in fact, we'll just do it together right now. If I just work with this portion, what does that reduce to? No.
3 factorial.
Good guesses.
It'd be 100 times 99.
Exactly. Because this one's 100 times 99 times 98 times 97, dot, dot, dot. And the other one is 98 times 97 times 96, dot, dot, dot. So all of this would cancel, just leaving you with these two terms. Ah, gotcha. So that's 9900 over, what is this? 2 factorial, which is just 2. So you could do it from there. Some of them will tell you overload because your calculator can't compute numbers that high, but if you use logic to reduce from reducing like this, your calculator can do it. Go ahead and tell yourself that. Okay. I'm just kidding. Yes, you are. Okay. Now, why they told us this for this reason. When you take any binomial, much like our DOM, you don't have to write this down. Let's say you had like x plus 3 to the 12th. You could use this formula, where you would use these binomial coefficients to help you with this problem. However, I'm going to show you, well, I'm going to show you the way I'm sure you've already seen before, what I believe to be an even easier way than that. And here is that way. Let's look at number 19. Actually, it's not number 19. Let's look at number 15. We're going to take 15 and look at that. When you start these problems today, because this is all you're going to be doing, you're going to do 1 or 2 of those binomial coefficients I showed you, but then you're going to do 3 or 4 of these. Somebody kick Braden. Head up, buddy.
No, Brady.
All right. Here's how you're going to start all day today. You're going to start with the first term, raised to this power, the fourth. Notice, why did I put the 2x in parentheses? Who can tell me?
Because if you had done x to the 4th,
Yes, I didn't quite hear what you said, but he was right, so I'm just going to go with him. That's correct. If you don't put this in parentheses, you're going to think it's 2x to the 4th, which it's not. It's x to the 4th and 2 to the 4th. So in a minute, we are going to have to raise that 2 to the 4th as well. Just remember to put that stuff in parentheses. So anyway, leave yourself some space and go 2x cubed, 2x squared, 2x to the first. And as a placeholder, you can go and put 2x to the 0, even though we all know that that's really just what? 1, right. But as a placeholder, we're going to do it like that. Next thing you're going to do, start at the other end and do the same thing with the second term, times 1 to the 4th, times 1 to the 3rd. Now I realize it seems stupid since it's 1, but it is going to be like 3 and 4 and things that are actually, you can do this to. So just get in the habit of doing this. Times 1 to the 1st, times 1 to the 0. Okay? I just started at the left-hand side and took the first term and counted down by exponent. And then I started at the right-hand side, took the right term, and counted down by exponent. Yes, but we're not quite there yet. Okay. Now, an easier way than doing that binomial coefficient formula it has in the book is to use Pascal's triangle, which I know you've seen before. It's, oh, I don't want to hear it. It's in your book. Okay, you didn't have to think about it. Okay. Here is Pascal's triangle as far down as we will need it. Now, the top row you won't use. This is technically, if you were to have like 2x plus 1 to the first, this is the row you'd use. So, we need the fourth row. 1, 2, 3, 4. Of course, it also helps wherever the 4 is, that's the fourth row. Guess what? Guess what number will be in that spot in the fifth row? 5. Okay, so we are going to take those 5 numbers, and those are our 5 coefficients. 1, 4, 6, 4, 1. Now, if you don't believe that you can do this, by all means, FOIL that 4 times, but you're going to get the same thing. So now all you have left to do is do all the multiplication necessary and combine like terms. So, what's 2 to the 4th? 16 times 1 to the 0, which is just 1, times 1, so there's nothing really to do to that one. 16x to the 4th. Plus, what's 2 cubed? 8. 8 times 1 times 4 is, what, 32? X cubed. What's 2 squared? 4. 4 times 1 times 6? 24. X squared, we're just doing 2 squared times 1 squared times 6, getting all the numbers out of the way. Okay. Then this is just a 1, so that's 2 times 1 times 4, 8x, and then what's the last one going to be? It's just 1 times 1 times 1, plus 1. Boom. That is 2x plus 1 to the 4th power. Question. Now, I'm going to go ahead and tell you this. What if this had been a minus 1? You can. When it's a minus 1, yes, technically all that will change here is that this will now be negative 1 to the 0, negative 1 to the first, negative 1 squared, negative 1 third, negative 1 to the fourth. You can just do it like that if you want, but an easier, well, what I believe to be an easier way, you don't have to do this, is essentially when you have a minus 1, you can do everything the same, just remember your signs are going to change, because a negative raised to the power is going to go positive, negative, positive, negative. So this would be a minus, plus, minus, plus. I'll show you an example of that right now. But if it's a minus, it's not going to really change much. Well, you'll see. No, they're going to alternate, I said. It's going to go negative, positive, negative, positive. I'll show you one. All right. Let's look at a tricky one. How about what? Yeah. So let's do 17 and then throw in a minus sign just for the fun of it. Oh, yeah. This is the hardest one I could fathom. Fathom. Isn't that a nautical unit? A fathom? I wonder why they use that. Freaks. Okay. So, eeny, meeny, miny, Melissa, how do I start this? Excellent. Very good. I'm just going to wait on my pluses because I have so much stuff to write, but you're right. Go on. Correct. Muy excelente. Awesome. Now what do I do on the other end? That's right. That's right. And then basically the same thing in the other direction. Thank you. All right. What? Oh, you have to watch that. Okay. Now, what's my exponent of the whole thing? Not everybody else wants 10. 4. So that means I need to go down to the Pascal's triangle row that has a 4 on it, which is that one. And those are my coefficients. 1, 4, 6, 4, 1. Now all I was saying earlier about the alternate signs, I'm going to go ahead and put plus signs here everywhere, which is fine. But all I was saying earlier is if you don't like dealing with the negatives, you can get rid of all the negatives. Just everywhere you have a, oh, that's b to the 0. Everywhere that you have an odd exponent, you'll just need to change it to a minus sign because that's not going to really affect anything. What's a negative raised to an odd exponent? Negative. So this one's going to be a minus. Negative raised to an even exponent is going to be positive. So that'll be a plus. Negative to an odd, negative. So it's just going to alternate the signs, but maybe you'll see that a little clearly here. If it's a negative exponent. Oh, yeah, I hear what you're saying. Yes, 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 yes. Okay, first term. What happens when you raise a power to a power? What do you do with those exponents? Multiply them. So x squared to the 4th is x to the 8th. This is just to the 0, which is 1. 1 times 1, nothing else to do. X to the 8th. What's this x going to be raised to? The 6. How many y's are we going to have? Just 1. I just like to knock out my variables first. And then I go back and do all the numbers. So 4 times negative 2 to the 1st. So 4 times negative 2 is negative 8. So this is going to be minus 8. X to the 6th y. Plus, what's this x going to be? To the 4th. What's my y going to be? That's right, squared. Y squared. And 6 times negative 2 squared. Squared, you've got to square your negative. So 24. And it'll be positive, right? Because negative 2 squared is positive 4. So 24, x to the 4th, y squared. Plus, well, we know this is going to be a minus. What's my x going to be 2? What's my y going to be 2? Cubed. And then 4 times, what is this, negative 8? Is that negative 32? So minus 32. x, well, you multiply the x's. That's why this one was 8, 6, 4, 2 for the x's. The y's, y to the 0, so there is none. Y to the first, y squared, y cubed, and this one will be y to the 4th. Okay, so how many squareds? It was the 4th row on Pascal's triangle, so 1, 4, 6, 4, 1. Oh, well, you take all the numbers in that particular term and multiply them. So here you had negative 2 to the first, which is negative 2, times 4, negative 8. Here you had negative 2 squared, which is 4, times 6, 24. You just take all the numbers in that term and multiply them all together. So I do the variables first and then just the numbers last. So, Kelsey, how many x's am I going to have here? What's 2 times 0? How many y's am I going to have? 4. And how do I get my number? Close. Alan, how am I going to get my coefficient here? Negative 2 to the 4th, 16, times just a 1, so there you go. That is x squared minus 2y to the 4th. Yay! Doesn't it feel like we've accomplished something? 3 or 4. Yeah, they don't take... They're not hard, they're just kind of lengthy. You have to remember a lot of stuff, but as far as difficulty, no. Questions about anything you see on the board right now? No? Okay. As normal, you're going to have just a few review problems, and we'll just forget those. Okay. Oh, darn it. Nope, nope, nope. There we go. Boom. There you go. Oh, poop. I didn't even save this. Thank you. Yes, 10.5. You will label this 10.5.